Welcome class, progressive waves, let's go. This is the introduction to this series. Of course, I've already released a video on waves. Endeavor to watch it. Of course, find it on our YouTube channel. Today we want to continue from where we stopped, and that is progressive waves. And then I'm going to give you a very simple formula, which of course at the end of the day we are going to prove. A is equals to Y is equals to sine of WT minus alpha. Note it very well. That is equation 1, and that is a bomb on itself. I'm going to continue driving the equation as we progress under this thing. Please bring out your jotter. Of course, I'm going to be telling you what this means. This is a displacement. Y is the displacement. Write it down. A is the amplitude. Write it down. Of course, you know sine. This thing is our angular. The W is our angular velocity. Now, of course, the T is time. This Q is the phase angle. Q is the phase angle. Q is the phase angle. I want you to know something. And if you have not watched my video on simple harmonic motion, it's on our channel. Endeavor to watch it. From simple harmonic motion, the angular velocity W is 2 pi f. Is it not? Yes, it is. And then I want to tell you something. The phase angle is 2 pi x all over lambda. This is my equation 1, this is my equation 2, and this is my equation 3. Now, look at what I want to do right now. I want to put both my equation 2 and my equation 3 into my equation 1, and it will change. Please, under this progressive way, immediately you do not understand this concept, you cannot solve it. It's not possible. So what I want to do now, from equation 1, whenever I see my W, I will replace it with 2 pi f. Whenever I see my angular or phase angle, I will replace it with 2 pi x all over lambda. And doing so, this my equation will now change. You will now have that y is equal to a sine of my W is 2 pi ft minus, rather than putting the phase angle of Q, I will replace it and put what? 2 pi x all over what? Lambda. Right? And this will be my equation 3. Are you with me? Good. Now, we're going to have to continue. We're going to have to continue. And what I'm going to do right now, if you watch this equation, you will notice that 2 pi is what? Common. So what I want to do right now is remove the common term outside. If I remove the common term outside, this will now be equals to y will be equals to a sine 2 pi all over. I want to remove this common term outside. So you'll be left with ft minus x all over lambda. And I should call this my equation 4. I just removed the 2 pi. What I did was remove the 2 pi. What I did was remove the 2 pi from the equation itself. And then we are left with this. So we are left with a sine 2 pi all over lambda. Now, look at what I want to do. Look at what I want to do. We know that velocity, v, is equals to f lambda. This should be my equation 5. Write this down immediately in your notes, because I'll be cleaning. As I'm solving, I'll be cleaning, and I will continue itself. So if this is this, now what I will do right now is, since velocity is f lambda, I want to make my f subject of the formula. So f is equals to velocity all over lambda. Are you with me? Now look at what I want to do. Look at what I want to do. What I want to do is, wherever I see velocity frequency from equation 4, I will remove it and replace it with v all over lambda. So what this equation will turn to right now is y, which is equals to a sine of 2 pi all over. Rather than for me to write f, I'm going to remove that f and replace it with what? Vt vt all over lambda minus what? 2 minus x all over pi. And that is how my equation is going to look like. Are you with me? Good. Now, I will call that my equation 6. This is my equation 6. Now, come with me. What I want to do right now, look at this equation very well. What is the common term? We have lambda as the common term, right? Good. Look at what I want to do right now. What I want to do right now is still remove that common term. If you are not getting this, I'm telling you, when we start solving, of course, it's going to be a lot harder for you to understand, which is the reason why you have to follow me as I'm writing it, jotting it down on your note. Now, look at what I want to do. I want to remove those pi. Remember from the equation here, we have y is equals to a sine of 2 pi into vt all over lambda minus s all over lambda. Now look at what I want to do. I want to remove this lambda here. So I want to take it out, making it to be the what? The common term. So this will give you y is equals to a sine of 2 pi all over what? Lambda. So you'll be left with what? vt minus x. That is what you'll be left with. Note it very well. And this is the equation we'll be using. It's another equation of the progressive wave we could also use in solving calculations. All these equations I am writing down that we are proving is what we'll be using to be solving equations throughout the end of this video. Those are very, very important throughout the length of this video. And of course, this is an introduction video to progressive wave. Meet me in the part 2 of this video when I'll be solving questions like never before.